That is more towards the end. If you look at your distribution, this one is called negatively skewed, and this one is positively skewed. So if you draw a bar chart and it follows that system, so this is, so far we've just been looking at bar charts. Yeah.
What if the data is just like completely random?
Yeah, then you can't comment on this. There is no skew. Yeah, it's not symmetrical, it's not positive. It's, yeah, there's no, yes, sir.
Can I have a book?
Yeah.
Oh,
Okay. So also we looked briefly at mean, median, and mode. The mean is the traditional average. It's add them all up and divide by how many there are. That's the very non-mathematical way of saying it, but add up all the data and divide. The median is the one in the middle. When you list from small to big, okay, so if you have the numbers, make sure to list them from the smallest to the biggest. If there's two in the middle, you get the average of those two, halfway between those two. And the mode or modal is the one most often. So with a very quick explanation, we'll just do a few numbers. Okay, we have 5 numbers here. To get the mean of those, I would add up all 5 and then divide by 5, because there are 5. To get the median, I would make sure to list them 1, 2, 3, 4, and 6. The middle one is the median, so in this case it is 3. Is the mode, if they're all just there once, is there a mode? There is no mode. If we had an extra number, 2 and 1, let's say, there are 2 modes, 1 and 2. If we had another 2 here, there's only, this is here 3 times more than anything else, so the mode is 2. So hopefully that makes, yes? Okay.
If it was like 1, 1, 1, 2, 2, 2, 3, 3, would you say that there's 3 modes or just no modes?
You can say there's 3 modes if you want. Yeah.
But like if that was all the numbers the same, like if it was an equal number of all the numbers, there are no modes.
I think they're, I've never come across that as a question before. Good question. I'm not sure. I would say no mode then, because they're all there the same amount of times. Yeah. Yeah, there's no mode. Yeah, so if it's 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, yeah. Don't think they're going to ask that, but okay. All right, so that's what we did yesterday. Moving along, then we need to know the range. So these are what is called the measures of center. Almost forgot what they were. These mean, median, mode measures of center, or traditional averages. We also need measures of spread. So how wide this direction the data is. So the measure of spread you would have done so far is something called the range, which is the biggest number minus the smallest number. So in this data set, we would have the range is 5. 6 is the biggest, minus 1, the smallest, which is 5. The range is 5. So you would have done that before, I presume. But then there's this thing called the interquartile range. I'll spell it right. Interquartile range, which is technically it's quarter 3, take away quarter 1. It's if median is halfway in the data, quarter one is 1/4 of the data, and quarter 3 is 3/4 of the data. So we look at what that means with an example now. But so median is halfway, but interquartile range deals with 3/4 way and 1/4 way, and you subtract those, whatever numbers. So that will also mean you have to list from small to big to do this. And we look at an example on the next slide. We won't use this.
Wait, so interquartile range is Q3 minus Q1?
Yeah.
What's Q?
Quartile. Yeah, it's quartile 3 minus, so quarters, quartile for quarter. So quarter of the data. So halfway is 2/4, if you want to say that. And we want 3/4 way. So if you see a set of data and it's listed, halfway is going to be in the middle here. This is obviously not listed yet, but 3/4 or 1/4 is going to be here, and 3/4 is going to be there. So you're looking at these two numbers and subtracting them.
Which two numbers?
Well, we haven't. I'll do, as I said, I'll do an example with, yeah.
Are the 3/4 random?
No, I'll do the example. I think it's better we do. So I have a couple of examples here for interquartile range. All right, so we got a bunch of numbers. We want to find the median, the upper and lower quartiles. So quarter 3 here is the one further along. That's the upper, and quarter 1 is the lower. So 1/4 way up the data and 3/4 way up the data. So let's look at the data that's on the screen, and I put it there. We'll get rid of these things. So as I put this data that we see on this screen in, I'm going to put it from smallest to biggest and hopefully not make any mistakes. I only see 1, 2. How many 3s do I see? 3 3s? 1 4. Thanks, Leslie. How many 5s is there?
1, 2, 4.
1 2 3 4. All right. 6s? 2 6s. 7s?
2, 7.
Any 8s?
1, 8.
1 8, 1 9. Okay, so here's our new set of data. First of all, let's find the median. So remember, median, we've never thought about it like this in quarters before, is 2/4 through the data or halfway in the data. A method when you get this many numbers is some people like to cross off the first and the last, and then you eventually meet in the middle. That's one way of doing it. How many numbers do I have here? 5, 10, 15. So what's the middle one going to be at?
7.5.
7.5.
Between 7 and 8. Between the 7 and 8. No, between 5 and 5. No, between 7 and 8.
All right, so remember, we did this yesterday. This is the first number. This is the 15th number. So added together, the average of the first and 15th number is going to be the 8th number, isn't it?
Yeah. 7 and 8 number. What did I say?
So you could do it crossing off as well. If I cross off the first, the last, second, third, fourth, fifth, sixth.
It's 5.
Have I missed 7th? Which one did I miss? Oh, this one. 7th, yeah. Yeah, I know, poor. So there's going to be 7 numbers this side and 7 numbers that side. Yeah.
Interesting.
Okay. So the median, or 1/4, is 5. 7 that side, 7 that side. Okay, what's going to be the 1/4 mark?
Oh, 3, 6, 9, 15, 14, 16. It's like 3.75. 16 divided by 4.
Okay, so the median is definitely 5. We're looking for quarter 1, quarter 3. Which is known as Q1, Q3. To find those, I need to get to the 1/4 mark of the data and the 3/4 mark of the data. So we have this set of data and this set of data.
You ignore the middle, sir?
Well, which side would you put it with?
The better one.
Neither. Now, if there's 2 in the middle, you would split them. So the one number goes with the lower quartile and one number goes with the upper quartile. So we find the median, or the halfway in this. And the halfway in this is going to be the lower quartile. So yes, you could do this system again. 1 from the end, 1 from the end, 1, 1, 1, 1, and the middle is 3 here. Does that follow? So the 1/4 mark, this is Q1, and it is 3. I have to do the same on this side. 1, 1, 1, 1, 1. I I get 7. So the interquartile range, IQR for short, interquartile range, which is Q3 minus Q1 is 4.
Oh yeah, right. So basically, you just take the median of
The median of the first quarter, or the first half, and the median of the second half. Yeah, exactly. Yeah. Okay. It's another measure of spread. So the range is probably less detailed about a measure of spread because we don't really know about the middle of the data very much. The interquartile range really tells us how spread out the data. If the interquartile range is quite large, that means the quarters are very far apart. That means you're talking about a larger range. Whereas the range is susceptible to what word did we use yesterday? Outliers, yeah. So if we use the salary example of yesterday, the range would have been way too wide. Whereas the interquartile range is probably a better measure of spread because it only looks around the center of the data and it removes any outliers.